let's give this expression a name since we're going to have to reference it a few times, folks. Let's call it E. E for expression. Forget F. So E of x, let's call this E of x in the functional definition sense. Computer programmers put dots there, I think. But for assignment statements. Again, so E of x is equal to this expression, and we want to find the last digit. Now, this seems impossible, but if you take a look at this, this really turns into more of a domain question, and the answer is actually a lot easier than you might think. Now, I went to a lot of trouble here to say that we're looking for real inputs and real outputs. All right, real numbered inputs right here, real numbered outputs right here. And the reason is it's certainly imaginable to put a complex number into this and then get a real output. So we're not interested in any of that, okay? So let's move along. Now, if you do trust these instructions, again, I'm repeating myself, but finding the domain is a very good idea here. So notice that if x is not equal to 7 or negative 7, this numerator is always going to be a complex number, which would likely make the whole expression a complex number. For example, if x is equal to 8, if x is equal to 8, this guy right here would become what? The square root of 15 plus root 15I, right? Now do the arithmetic correct, folks. If you put the I there, y'all remember I means I squared is equal to -1, right? Or I is equal to the square root of -1, either way. But if you put an 8 right here, you get minus root 15, which evaluates to root 15I. All right, so this is a complex number, and so it's easy to believe that that's a fact for any number at all other than 7 or negative 7. But also note that E at 7, E evaluated at 7 leads to a division by 0 right here. So I'll say undefined. E at 7 is undefined because you have a division by 0 going on right here. Undefined. Undef abbreviated, undefined, right? And what about negative 7? Well, E at negative 7 okay, gives us, just for the sake of, it'll give us 0 up here, but it will give us 14 downstairs, so that'll be 0 over 14. Just for emphasis, you say E at 7 is just undefined because you're dividing by 0 here, but E at minus 7 would give us a minus, the absolute value of minus 14, so it's 0 over, okay, 14, plus, and here's where the last digit is going to come out. You see, if you put minus 7 right here, this gives you 6 raised to the 2024, the year that it has been, and the year it will be. Okay? That was our question. Find the last digit. Well, gosh, didn't this work out pretty easily? The last digit of this is certainly 6, right? So the last digit is 6. Done. Last digit 6. That's provable in elementary number theory. I think everybody knows that if you elevate 6 to 6 powers, 6 to the first is 6, 6 to the second is 36. 6 cubed is 216. Now that 6 to the fourth is 1296. That's not a rigorous proof, but you can prove that fairly in a straightforward fashion in number theory. But the last digit is 6. Which is the answer. Yeah, and so if you really want to get more into this problem, it really is a domain question. And retrospectively, the domain of this function, sometimes that's the best thing to do, y'all, is look at the domain. It really simplifies a lot of problems. Some people just want to dive in and start working it. But the domain of this expression is the singleton -7, right? that is the only real number where this is defined. That's cool, right? So that's all we got to worry about. And then, of course, when you put minus 7 right here, you get 6 to the 2024. Hello. Okay. Now, again, all you people that love domain and range, the numbers are abundant. The range is also a singleton, which we will certainly write in integer or exponential form. That's 6 to the 2024. Yeah, I don't want it. Yeah, unpronounceable number, right? Fairly cool problem. I like that one a lot. And so the last digit, of course, since this is the only element of the range for real values, the last digit is 6. Hope you enjoyed that.